Hello dear students, in the previous session we have learned the basics of graphs, nodes, edges, directed and undirected graphs, degree and neighborhood. In this session we will learn graph representation. Once we create a graph, we need an efficient way to store it inside a computer. Computers cannot understand diagrams directly. So we have to convert graphs into data structures. Today we will study three common graph representations. So the common graph representations are adjacency matrix, adjacency list and edge list. These are widely used in graph algorithms and social networks analysis. So the topic covered are adjacency matrix, adjacency list and edge list. Each representation has its own advantages and disadvantages depending on the application. One representation may be better than the others. So why do we need graph representation first of all? So suppose I draw a friendship graph on the board with 10 students and their friendships. As humans, we can easily understand the picture. But can a computer understand this drawing? No. Computer needs the graph to be stored in a structured format. A good graph representation should store all the graph information accurately, allow fast searching and updates, be suitable for mathematical operations and graph algorithms. So instead of drawing graphs, we store them using arrays or lists. So the first type of graph representation is the adjacency matrix. So suppose our graph has 5 vertices, we create a 5 cross 5 matrix. Here the graph contains 6 vertices, so we are creating the 6 cross 6 matrix. So rows represents the source node, columns represents the destination node. Each cell tells us whether two nodes are connected. Draw a small table on the board. So 1 means there is an edge, 0 means there is no edge. So this is the representation of adjacency matrix. So that understanding the adjacency matrix, let us how to for example, we are having this vertices 6 vertices. So in the rows we are representing 6 vertices as v1 to v6, and in the column also we are representing the 6 vertices v1 to v6. So if there is an edge from v1 to v2, we are representing as v1 to v2 equal to 1. So likewise, if there is an edge represented by 1, if there is no edge, it is represented by 0. They represent self loops, meaning a node is connected to itself. So okay, in social networks, people don't become friends with themselves. So diagonal values are usually 0. So the next one is adjacency list, which is more memory efficient. Instead of storing every possible connection, we only store the neighbors of each node. Think of it like your phone contacts. Your phone stores only the people you know, not every mobile number in the world. Similarly, each node stores only the nodes directly connected to it. For example, V1 is connected to V2. V2 is connected to V3, V1 and V4. Likewise, it follows. So suppose we have 4 students. A is friends with B and C. B is friends with A and D. So it is represented as A to B to C, B to A to D. So the advantages of adjacency list is it uses much less memory, very efficient for sparse graphs, easy to find neighbors. Most graph algorithms like BFS and DFS use adjacency lists. So the next type of graph representation is an edge list. Instead of storing rows or neighbors list, we simply store every edge. Each row contains one connection. For example, V1, V2, V2, V3, V2, V4, V3, V4. So, suppose a road connects Chennai and Coimbatore, the edge list simply stores Chennai, Coimbatore. Another road connects Chennai and Mumbai. Then we can store Chennai, Mumbai. This representation is very useful when we only need the list of edges. So many graph algorithms begin by reading an edge list. So comparing all these three representations, So adjacency matrix is best for dense graphs and the memory usage is high. Adjacency list is used for sparse graphs. The memory usage is low. Edge list is used for reading or storing edges. The memory usage is very low. So remember that the matrix is fast connection checking, list is memory efficient, edge list is simple storage. So let us have a quick activity. Consider a graph. A is connected to B and C. B is connected to C. C is connected to D. Can you represent it using adjacency matrix, adjacency list and adjacency list? Okay. Today in this session we have learned why graphs may be represented in inside computers, adjacency matrix and advantages and disadvantages, adjacency list and why is it is widely used in social networks, edge list and its simplicity, and then comparison of all these graph representations. In our next session we will study types of graphs including simple graph, multi-graph, weighted graph, and connected graph, bipartite graph and complete graphs, which is very essential for understanding real world network structures. Thank you students.